To reduce channel erosion of row crop fields within a floodplain, the Illinois Department of Conservation has tested stabilization practices that use low-cost stream bank vegetation. The department funded a stream restoration program of the Knox County Soil and Water Conservation District in the Court Creek watershed near Galesburg, Illinois. In this scene, the Illinois State Water Survey is monitoring a flood to determine the effectiveness of the district's erosion control measures. The survey compares the amount of bank erosion with the amount of sediment carried away by each flood. Notice the erosive power of the floodwaters passing beneath this bridge. The powerful current actually pulls small trees underwater during major floods. Landowners have developed a watershed motto: slow the flow, because erosion of the stream bank has become the most serious form of flood damage. The degree of bank erosion that occurs at any one site is the result of a combination of two factors: the velocity of the floodwater and the instability of the banks of the stream. The action of the current causes large chunks of unstable bank soil to fall directly into the swiftly moving floodwaters. All of the eroded bank soil is carried downstream, where it causes sedimentation damage to downstream rivers and lakes. Even turtles are eroded from the stream bank, right along with the soil. Stream segments that have been channelized and do not have wooded banks can easily lead to the erosion of 2,000 tons of soil or more from adjacent fields during a single flood. This row crop soil is replaced by a huge sandbar, which is composed of 90% sand and gravel. The farmer has unwillingly traded prime farmland for sand. 50% of the sediment carried by Court Creek is eroded from the stream bank during floods. One way to stabilize stream banks is to protect them with large willow posts. The dormant willows are cut after their leaves have fallen off. They're transported to the bank erosion site. With Department of Conservation funds, the Knox Soil and Water Conservation District has begun field conservation trials with the assistance of the Soil Conservation Service. At one site, holes were formed with a 6-foot metal ram attached to a Caterpillar excavator. After determining the correct position for the posts along the toe of the bank, the spots are marked with flags. The excavator forms a hole at each flag site. The large willow posts are placed in the holes and begin to grow roots and then branches. Smaller willow cuttings are placed between the larger willows to trap sediment. At smaller installation sites, a gas auger can be used to dig the holes for the willows. This is less expensive than using the excavator. Seedlings of more desirable trees are planted among the willows and along the upper bank. The seedlings of green ash, hawthorn, bald cypress, and gray dogwood will shade out the willows when fully grown. After 8 weeks, the willows have developed root systems and branches. During the initial regrowth period, it's possible that infestations of the imported willow leaf beetle may have to be sprayed for control. The smaller cuttings are also growing rapidly and have developed extensive root systems that stabilize and bind the soil in the stream bank. 5 months after planting, a flood tests the ability of the willows to protect the stream banks from erosion. Notice how the willows slow the floodwater currents near the erodible soil areas along the lower bank. After the flood, inspection of the site by project personnel found no damage either to the bank or to the covering vegetation. Beaver dams should be removed in order to stop permanent flooding of the willows during the first summer. Any bank protection structure is subject to severe damage from ice flows during winter flooding. 9 months after planting, this site experienced a severe ice out when very large ice flows were driven into the willows by floodwaters. The largest ice flow was 15 feet by 9 feet and weighed over 3 tons. And yet, only 13 of the 620 willows were broken off. By the spring of 1988, even those willows that had been severely scraped and broken had regrown branches. Here, one willow post is growing again after being flattened by the ice flows. One advantage to living systems is the ability of such systems to recover from flood damage without expense to the landowner. Even the bald cypress seedlings planted among the willows are growing rapidly. Landowners frequently try to improve streams by channelizing across the sandbars on the inside of stream bends. Such channelization shortens the length of the stream and increases the velocity of the floodwater, while severely damaging the stream habitat. At this willow site, the landowner attempted to move floodwaters away from his most valuable farmland at a cost of $1,500. The channelization attempt was short-lived. During the first flood, the newly constructed channel was filled with 10 feet of sand and gravel. Channelization caused a severe test of the willow bank protection. The stream blew through the upper end of the dike so that floodwaters smashed directly into the willows. No erosion occurred, however. Without the willows, the floodwaters would have eroded away 1,000 tons of soil. After the flood, the stream returned to its original channel. Rock and gravel fill the channelized reach. Despite numerous beaver, this site has remained stable 5 years later. This pilot project has led to statewide funding for the cost-share practice of willow post bank stabilization. Soil and water conservation districts from Illinois and other states have participated in training workshops, which include the stabilization of eroding banks, such as this site near Peoria, Illinois. Workshop participants include contractors and personnel from state agencies, the Fish and Wildlife Service, and the Soil Conservation Service. In these workshops, participants stabilize large bank erosion sites. With a local contractor, they slope vertical banks to a 1-to-1 grade, install willow posts, mulch the site with cedars, and seed with grasses, all for a cost of $6 per linear foot. The advantages of a hydraulic auger are shown on difficult stream banks. The auger performs better in sands or glacial rock by making deeper, longer-lasting holes. At the same time, classroom demonstrations answer common questions from landowners concerning the proper care of stream banks.
For years we've been cleaning out these ditches and straightening them out. When do we not do that, and when do we go this other direction?
The causes of increased bank erosion are explained through the use of a model stream. How gravel mining and channelization lower the stream bed and increase bank erosion are shown in this model stream. This animated sequence shows how water currents scour the stream channel deeper and wider if velocity is increased. Field tours show how naturally occurring vegetation is eroded away with bank soil if the stream cuts below the root depth. The same problem occurs if willow posts are not placed below the maximum depth of pool scour or downcutting. This illustration shows the proper depth of placement for the willow posts to avoid undercutting. Private landowners provide land for the wooded stream banks by giving up a portion of their floodplain fields as conservation easements. In intensely agricultural regions of Illinois, the development of stable wooded streams results in highly desirable habitat restoration for man, game fish, and upland game.